Hey, welcome everyone to another episode of the TrueNAS Tech Talk podcast. On today's episode, with the launch of TrueNAS 2504 just a few days away, we're pleased to have a very special guest with us here today. We'll be sitting down with Stéphane Graber, the founder and architect of the Incus project. With Incus making its first public debut inside TrueNAS this release, we're excited to give everybody a little bit more insight and information into the history of Incus and how it might be used externally as well, performing the heavy lifting of containers and virtualization on TrueNAS going forward. Welcome to the show, Stéphane. Thank you for coming.
Hello.
Hey, glad to have you here. Long time coming. This is exciting and perfect timing. I mean, Fang 2 is about to come out in just a few days, Tuesday of next week. So a lot of people's first introduction to Incus may be happening this next week. So again, great opportunity.
Yeah, it's quite exciting to see. And we've definitely seen some people show up on our side now mentioning that they've been using the release candidate and been playing with Incus that way, discovering Incus that way. So it's quite exciting to see where that's all going.
I don't have to apologize for any forums bad behavior, do I? If I do, I'm sorry.
Everyone's behaved so far, so
okay.
That's been good.
Keep it up, folks. Say, don't let me down now. Let's keep it
nice.
polite.
You're representing the TrueNAS community, so play nice.
That's right. So, hey, Stéphane, let's go ahead and get into it. So before we get it, kind of knee deep into Incus, I want to talk about you a little bit first, since this is a lot of folks' first introduction to you. So give us a little background on yourself. When did you first get into computer science, software development? What kind of brought you to this point?
Yeah, I mean, I've always had an interest with tinkering with computers, and then I probably got my first when I was 10 years old or something. I had like my first own computer, just like put together from spare parts. It wasn't even like a 100 megahertz CPU yet. It was like 90 megahertz or something at the time. Played with that for a while. Actually got onto running Linux very, very early on because that's what was running best on that, honestly. And then got into pretty quickly running home servers, home websites, email server, all that kind of stuff. Also like pretty early on, and starting to slowly contribute back to the Linux and open source community because things were pretty darn rough at that time.
Yeah, I was there. I can remember.
Yep. So there was a lot of like, oh, okay, I just got this new piece of hardware, and like it's not working. So let's figure out like what's wrong and send some fixes, at least file good bug reports, do that kind of stuff, and kind of taking it from there.
Yeah, coming from the BSD side, I spent a lot of time looking at compiler output in my day. So it was fun.
Yeah, when I think back of kind of some of the early days, I remember some of the first laptops I got, like it was like Pentium Pros or those kind of things, were like pretty early on laptops. And as soon as they started introducing ACPI, things would just not work, really. So spending a lot of time decompiling ACPI tables, fixing them up, compiling them back, loading it through the Linux kernel at boot, trying to get that machine to mostly behave the way it's supposed to. We've got it easy. It just works way too well these days.
Yeah, I say I don't mess those days. ACPI in particular was a pain in the rear to deal with, especially because it always, the joke was on the BSD side, like, we can suspend awesome. It's just resuming we kind of suck at.
Yep.
But as a follow-on, I got to ask you, what was your Linux distro journey, I guess, or what is your current distro choice? Because that's always curious.
I did a bunch of kind of distro hopping at the beginning. I think I started with Mandrake, which became Mandriva and all that stuff eventually. But I reasonably early on I ended up, I did quite a while on Gen 2 actually for when I had to fix everything anyways. I might as well compile everything anyways,
Sure.
But no, after maybe a year or two on Gen 2, I had switched to Debian. And then I heard of that project that at the time was called No Name Yet, which I started to hear a bit about, start using it. And that turned into that small thing called Ubuntu.
Might have heard of it.
Yeah, even might have heard of it.
A couple people use that one.
Yeah. So I've used that for quite a while, basically up until about 2 years ago when I left Canonical, at which point I've moved back to Debian these days. So I'm back to normal Debian. It's still mostly the same thing, honestly. Like Debian or Ubuntu, it's pretty interchangeable. So
Hey, a little braver than me. I'm on Ubuntu right now. I just haven't quite got the gumption to go and say, I'll go vanilla Debian and do it more manually. I get lazy. So, Stéphane, did you work on any projects before LXC and Incus, and what were those? Anything we might have heard of?
Well, as mentioned, there's that small project called Ubuntu I was kind of involved with. So yeah, I mean, I did a bunch of other open source projects, kind of like in my early days of open source. The probably most well-known of those that people might have used at some point is a small Python tool called PasteBinet, which was just used to like take whatever command output, pipe it into that thing, and you get a URL back. So that's been pretty popular. These days, it's a lot less so because you've got GitHub.js and those kind of things that work online and work really well for that kind of stuff. So it's not really that relevant. But that was, I think, the first piece of code I wrote that shipped by default on all Ubuntu systems, effectively. So that had a decent spread that way, and a bunch of other distros picked it up. I think it was even used like commonly installed on macOS and a bunch of other things for a while.
Oh, nice.
So that was one of the first things. But yeah, then as I mentioned, while I was going through school, one of the things I was doing because I was getting bored was helping with testing for the Ubuntu project. So I was doing all of the kind of manual pre-release testing for all of the different, at the time, CD images we were making. Validating that in a bunch of different languages, different system, different type of partitioning, all the massive manual test matrix. Doing that through just wiki pages was getting a bit annoying. So I wrote a website to handle all of the all of the ISO testing, effectively, ISO testing and validation, which is still used to this day because nobody, like everyone hates it, but nobody actually wants to spend the time to redo it. And I'm also in the camp of those who actually hate it, to be fair, because that, like, I did that in school. We had to do PHP stuff at the time, so I wrote it in as a PHP Drupal plugin, effectively, which we've then ported to multiple long-term support releases of Drupal to just keep the thing going. But nobody in the Ubuntu project likes doing PHP. I've not done PHP in decades at this point. So I don't really want to deal with that beast. But it's still used to this day because it's one of those things where like it's specialized enough, it does the job enough that so long as people can just port it enough that there's no massive security issues with it, it's fine. So I kind of did that for Ubuntu for a while, but I eventually also I did more and more packaging stuff. I became an Ubuntu so-called Master of the Universe, which are the folks who can upload most of the packages in the distro. And then from there, I became the Ubuntu core developer, which kind of also lets you modify the rest of the distro, like all of the core packages. And I think at that point is when I joined Canonical. So I did all of that pre-Canonical when I worked for a small company around here in Canada. And then when I joined Canonical, I did even more Ubuntu stuff because I joined the Ubuntu Foundations team, which is effectively responsible for anything that's between the kernel and the desktops, like all of the early boot stuff, basically. So I worked, I was one of the developers on Upstart, so the init system at the time. I did most of the IPv6 enablement for Ubuntu at that time. IPv6 was still a thing that was becoming finally more common at ISPs, so I did a whole bunch of work to make sure the server-side infrastructure supported it, but also all of the different clients, and I was maintaining all of the network management tools, so making sure that all of those handled IPv6 correctly. So I did that kind of stuff. I also joined the Ubuntu release team and the Ubuntu archive admin team, so I was doing all of the reviews for new software, all that kind of stuff, like some of the legal stuff, like validating licenses, compatibility, all that kind of thing, but also just general quality of the packaging and that kind of stuff on the distro side. And then we had, I always had an interest for containers. I was actually doing some of that at my job before Canonical. I was working, we were using Linux vServer for a little while over there, and then OpenVZ after that. And that worked fine, but that required like custom user space and very, very heavily patched kernels, which were not super fun. So I also kept an eye on that LXC project thing that was starting to show up, that was just driving mainline kernel features. It was nowhere near feature parity, but it was getting there. And so I kind of got involved with that, especially after I joined Canonical. We actually hired at Canonical Serge Hallen, who had been working on LXC for a bit at IBM prior to that. and started putting more resources into LXC, effectively, leading to me becoming the upstream maintainer for LXC after the previous maintainer moved on to power management stuff in Linux instead. And
you've had a lot of history, though. It seems like you've had a finger in just about every area, which is great because you have kind of that broad knowledge of how to stitch all these things together now.
Well, yeah, I mean, that's coming pretty handy these days because, my job for a while was literally maintaining, I don't know, in the thousands of packages, effectively. Like every day you'd be fixing bugs in something else. So I've been pretty good at picking up random code bases very quickly and figuring out what's going on. I know how to build a distro because I effectively worked on building one for years. I've got a pretty well-rounded understanding of how everything works on Linux. I've contributed kernel code as well. Like I'm not a kernel developer, but I'm decent at doing kernel feature design and then have other people implement them. So I mean, the only thing I try to mostly ignore as much as I can is like firmware.
Smart man.
I tend to test and complain when it doesn't work, but try to stay away from actually being involved with that as much as possible. But yeah, effectively, like, we started doing that LXC thing at Canonical, which kind of came in handy because it was around the time Canonical was looking at doing the Ubuntu Phone. And for the Ubuntu Phone, I'm not sure how widely known it is, but it was effectively off-the-shelf Android phones that were being used to run Ubuntu on. And when doing that, there's a bit of a problem with things like the radio and some of those more telco bits. So the way it was handled was that we were running Android in a container on those phones. So the phone itself was booting Ubuntu bare metal, but then we had an Android container running, amongst other things, the old telco stack, and then integration going back and forth between that and the OS. So that was one of the first justifications for having like really a bunch of paid time to work on LXC, was when it is to make that stuff work. And I kind of went from like, okay, that worked pretty well. People also like working with LXC standalone. So that became more of a thing as part of Ubuntu server. And then we wanted to improve the kind of user experience around that tool. And that led to the development of LXD, which I then ended up leading for a number of years before I left.
Okay. I actually used an Ubuntu phone for a little bit there. It was, I think, as you mentioned, the radio was one of the challenges. I want to say it was like a Nexus 4 kind of era is one of the things I used Ubuntu Phone with.
Yeah, we did a bunch of development on the Nexus 4, and then there were a couple of kind of first-party phones that were like literally being sold with Ubuntu pre-installed on them. There was like one from Meizu and one from some European company. But both of those phones already existed, were normal Android phones normally. They just had like a different SKU for different image.
Yeah. Interesting that Ubuntu Phone is kind of like sort of the genesis of putting a lot of the funding behind that project. It's not what I would have expected. I would have thought it would have been like a security-driven issue, but the itch in particular was kind of like the closed firmware almost of the telco companies to say, no, you can't have access to our radio blobs. You gotta, so you would containerize them in an existing Android environment. That's
yeah, exactly. I mean, the rest of the system, like there was some isolation for the applications, but that wasn't using LXC or containers. That was using, at the time they were called Click, which turned into Snap packages effectively. So that was like the very early days of Snaps was on the Ubuntu Phone. The concept was there, but was actually completely reworked to turn it into Snaps down the line. I mean, the Ubuntu Phone was an interesting experiment. Like it was interesting work to do. Like I did effectively two things on the Ubuntu Phone, the container layer thing, and I did the OS update mechanism. So like both the server side generating deltas and the flasher and stuff on the phone itself to apply the full OS updates. And it was all interesting work. It's very debatable whether it was work that was worth doing.
Well, I was going to say, I wouldn't have guessed the phone, but sometimes it's the side projects that spin out of the main project, which become more interesting over time. So that's not a bad thing.
Yeah, I think Canonical got some amount of value that way. Like the work on LXC and the work on Snap kind of came from the phone. A lot of the rest of the work was just lost. Like the work on the phone shell and all that kind of stuff was all thrown away and be replaced by norm shell on the desktop side. I mean, the biggest issue really when you want to make a phone like the Ubuntu Phone is, and you want it to be successful, is at the time there were already 3 players. I mean, and one of them was small, but we were going to be significantly smaller than that small player too. Like obviously we had, Android, iOS, and Windows Phone, and we were going to look at maybe being 10% of Windows Phone if we were lucky at the beginning, which is a bit of a problem when you're trying to build an ecosystem. Like nobody wants to port their applications to the number 4 platform. They don't even do it for the number 3 platform.
And even the number 2 is a pain sometimes.
Well, and what you end up doing is like, I mean, I remember having those discussions of we wanted to have like a Twitter client or something. Well, you wanted a Twitter client, we're gonna have to shell up front like $500,000 or something, because they were not gonna port their application unless they were being paid to do it. And you can't do that for every single app you want to have at launch. Like that's just not practical. That's why the Ubuntu Phone was being pretty hard on using web apps as much as possible to try and work around that problem. But it was still pretty early days for that. Like all of the nice frameworks for web apps and stuff just weren't really there.
You're kind of ahead of the times in a way, because so many apps now are just like web apps in a container that are just running on top of whether it's Android or iOS. So
it would probably be easier now, because a bunch of people took that shortcut these days of like, I don't want to have a native app on both Android and iOS. That's annoying. So let's just take our web app and ship it with a small layer around it.
Let's write it in Electron and then just let the native things handle it there. So I mean, there's got to be dozens of us out there who miss Ubuntu Phone. So sound off down in the comments if you've got an old Nexus and you're going to go throw Ubuntu on it right now just to remember.
I mean, the funny thing is that the Ubuntu Phone project, even though Canonical canned it a long time ago, it's still going. There's a project called UBports, which is like a community project around it that still maintains images for a number of Android phones based on that Ubuntu Phone image and still keeps it up to date. So it's still possible. There's still people using that for sure.
The beauty of open source right there. It's like, I don't want to be done with this. Let's find this very niche community of us, and we've got the skill to keep it going, so let's do it.
Yeah, exactly. And I remember like one of the other kind of rough things with the Ubuntu Phone was just like, the web apps, okay, even if they work, that'd be nice, but there was no support for offline web apps at the time.
Yeah.
So if your phone lost network, which at the time what happened a lot more than it does today, you just have nothing.
You're toast, right? You just get a blank screen.
Yeah.
Oh man, that's wild. Well, you actually partially answered my next question, which was going to be asking about if LXC style containers are the first things implemented, or if you went with QEMU. So I guess I'll rephrase the question. At what point did you guys say, you know what, we need to also have the full QEMU virtualization as part of this as well? And how did that decision get made?
Yeah, so going back a bit on the history of the LXC project there, and when LXD started, it was really meant to be like a better user experience on top of LXC as a way to. LXC effectively grew over time as the reference implementation for what container features existed in the Linux kernel. And at the beginning, basically nothing existed. So as more and more namespaces and features and things were added, that was added one by one to LXC. Which is a bit of a problem when you want to have backward compatibility, because it means you don't get to use any of the shiny new stuff by default because you need to be backward compatible. So that made it pretty clunky to get a good experience out of it. And with LXD, we're basically thinking, well, we're now at a time where most of the features we would ever really want are there. Like all of the foundational features are there. It's a good time to kind of try and reset the experience. So that's where we were, okay, we want to do containers. We want to do image-based, like pre-installed, download an image from a server, just run it immediately. No need to mess around with creating your own local file system and all that kind of stuff. Also having more, like easier to manage networking and storage. Because before it was effectively a world of, we can consume whatever you have, but it's on you to have done everything already. With LXD, we had the opportunity to kind of improve that. Even though the first version of LXD didn't really do much on networking and storage, I think very early on in the first 0-point-something releases, we added the networking piece, and then the multi-storage driver thing also came on pretty quickly.
Yeah, we saw that you have a built-in ZFS driver. That was one of the things that really kind of caught our attention from the TrueNAS side. So you said that was added in a fairly early version. Like, was there something ZFS specific where you like said, hey, we want to write our own driver for this? We want to get in there?
ZFS was one of the very, very early ones. Yeah, I mean, initially we did directory because that's the obvious one. It's super easy, but a lot of things make no sense on directory, like doing snapshots when you're just on a basic directory tree, yeah, we support it by doing a full rsync of the entire thing, which is not pleasant.
Yeah, you don't say.
Yeah.
Us CFS guys, we get spoiled because we forget people don't have that natively.
So yeah, LVM was added pretty quickly, as at the time that was kind of the default option on Ubuntu servers was LVM, like an LVM VG was there. So hey, we can to just use that, and so we supported LVM thick and thin pool, probably in the first couple of 0 point something releases, but LVM, at least at the time, and I think even to these days, can get pretty frustrating. We had a bunch of weird race conditions, metadata corruption, cache, all that kind of stuff, which was not a problem when someone would use it on a normal system and just use it as like a fancy way to partition your disk, and you just kind of, you might create a new LV every few months. When you're talking about what we were doing, like in our test, we were creating about a dozen LVs per second. We were starting to hit weird race conditions and problems, which sure, most of them have actually been fixed by now. We're back to using LVM for some of the complex cluster stuff on top of Fiber Channel and the like these days, and we don't have that problem anymore. Also because in that environment, we can't do thin provisioning, we can only do thick, and there's a lot less issues with LVM if you only do thick provisioning. So yeah, we did LVM then, but ZFS was already something we were looking at the distro level at that point. I think, yeah, we already had it packaged, and we already decided to start shipping it as part of the Ubuntu kernel at the time. And so it made a lot of sense to add support for that, because like, on paper and even in today's day, it's basically magic. Like it does everything we need for containers. And even when we got into VMs, like, hey, it also does that very well, as it turns out.
Right.
So yeah, that's been kind of an interesting thing. And, going into the history, we effectively introduced clustering even before we did VMs. We really tried not to do VMs for the longest time.
Okay, so you resisted the urge for a while. I get it.
Well, yeah, I mean, like we didn't want, at the time, Libvirt was very actively developed, and we're like, we don't really want to go and compete with these guys. My expectation when we created LXD was that Libvirt would come to also evolve in the same way we did, and it would get like a REST API, and it would turn into more of a usable tool than it was. And after a number of years, we kind of looked back at it and we're like, well, none of that happened. Fine, we'll do it ourselves. And that's when we added VM support to LXD, because we had so many features in LXD that were already VM-like on the container side. Like you can see number of CPU, amount of RAM, all of those kind of resource limits. It's basically like we were trying pretty hard to have our containers feel like VMs. So it wasn't that much work to then actually add VM support. It's like, okay, well, fine, we'll just do it. And the main reasons for not doing it to that point was we were expecting another project to be really focused on VMs and come along and we didn't want to compete with that. It didn't really happen. So there we go.
Well, even internally, when we were starting to do the development using Incus and TrueNAS about 4 or 5 months ago, it just kind of made sense. The natural idea of, I have an instance, some of them are lighter weight LXC, some are heavier QEMU backed VMs. Because at the end of the day, you're still talking about virtualizing something, right?
Yep.
And there's just some little differences in the technique, but it just makes sense. So it feels good. I'm glad you guys eventually did steer that direction.
Yeah, and we've kind of kept going, and you mentioned we did containers and VMs, and then a feature we added to Incus that LXD doesn't have is we support running OCI containers. So we can run Docker type images natively directly on Incus, still feeding it to LXC behind the scenes, but like we understand how to handle those different kind of containers that run just a single application. And now we're looking at doing the next step of that, which is, again, now we can also add a VM flag to that. And then if for security reasons you want to run some kind of Docker container, but you don't want to run it on the bare metal on the shared kernel, you'll be able to run it inside of a thin VM layer. Again, not something particularly new. I mean, Kata containers have been around doing that for a while. It's another piece of the puzzle we can just add, and it will fit extremely nicely because we already have a VM flag. We already support OCI containers. Hey, how about we put the two together, and there you go.
Yeah, it's just a different checkbox. From an end user perspective, having that flexibility is so nice. But getting back to the fact, so we're got a lot of TrueNAS audience here are probably going to be curious. So I'm going to ask the question, what are some of the main differences between the different storage drivers in Incus? Because again, you do some cool ZFS things. Are there any unique ZFS features that you guys leverage more heavily or like, I guess that's where some of our TrueNAS folks will go, oh, I know what they're doing there.
Yeah, I mean, mostly what you would expect. I mean, the support for quotas is a lot better than it is on just about anything else. Like having that work properly is quite nice. And send receive when moving between machines, that works really well as well. We use a few other things, and we've got knobs for setting like the block sizes and those kind of things on a per volume basis, which is pretty useful for large databases and those kind of workloads. Otherwise, I mean, it's for like containers. If you compare it to, say, BurFS, the feature set is not that different. BurFS has some weirdness around quotas, like the quota group tree that they have is kind of distinct from the data tree, which means you can pretty easily bypass your quota by creating like a nested subvolume inside the container, which is not great for anyone who wants to actually enforce quotas properly. So that's
flexible for the client, not so great for the administrator.
Yeah, exactly. So that's a bit of an issue. For the longest time, BurFS was interesting because it was the only one where we could delegate the creation of subvolumes to the guest OS. But ZFS does that these days, and we've added support for it, obviously. So we've got the delegation support as well. So now,
and as a bonus, you have functional parity rate as well on ZFS.
Well, there's that too. Yeah.
Little features. Again, we take it for granted. We don't even talk about it half the time here because it's just been part of it forever now.
Yeah, I mean that's like definitely on the backing side, ZFS is a lot more flexible and reliable. Like you've got a lot more options on how you want to structure your actual underlying storage, what kind of level of replication you want, and then a lot more knobs there than you do with BurFS. BurFS has the inferior nicety of being able to shrink in a cleaner way than ZFS does. Like ZFS does pull shrinking now, but it's still a bit of a hack the way it actually works internally. BurFS has a better design for that. The problem is these days people seem to be happy with BurFS in some cases. My personal experience is that I lost a lot of data to BurFS over the years. So when you mentioned the RAID stuff, RAID 1 was tolerable. Anything else, I would not touch it. Again, I've heard they've done a lot of work over the past couple of years to really revamp that stuff. So there's a good chance it actually works now. But I've had issues with BurFS RAID. I've had issues with BurFS compression, both of which kind of caused corruption in some cases. I got pretty good at using like the BurFS inspect and debug tools to like extract data back from my broken file system.
Oh man, but having to do that is such a pain.
Exactly.
One of the quotes that always sticks with me at some of the conferences I went to, the ZFS guys, we had this saying: file systems are hard. And you can't state that enough. It is a really hard computer science problem to solve. And it takes these file systems a lot of time to mature and reach any kind of enterprise level functionality where you can trust and feel good that it's not going to munch my data inadvertently.
Yeah. I mean, it's interesting because we get some amount of statistics on the storage that's being used by users. Whenever they talk to the image server, effectively, we get a bit of a glimpse as to what they've got enabled on their system. And directory is still usually the most used because that's trivial. It just works. Like if you do the just -- auto, just get me something, that's usually what you get out of the box. So that's fine. And BurFS was usually the second one, mostly because I think it's Fedora and some other distros use BurFS for the system. And so we pick it up doing initialization, being like, hey, your system is already on BurFS. You just want to create a new subvolume and go with that. And people just say yes, and they use that. So that was the main thing. And then recently, we've seen ZFS kind of go up and up and up and up and up. And when looking, when digging a bit more into what OS it's running on and what version of the kernel and ZFS it's using, it's weird. It's Debian 12 with a recent kernel and a recent ZFS. Wonder who that might be.
I don't know. Where did that come from?
Who could that possibly be?
Yeah,
that's funny. You've even noticed, and we're still in a pre-release state. You wait till we get the release out here next week. Holy crap!
Yeah, exactly. That's what we're looking at. Like, okay, well, that's gonna be interesting to see what kind of spikes we get when people start using it, because we're seeing in the tens of thousands of systems that appear to be running TrueNAS. And yeah, that's still a release candidate, so it's interesting.
It's still a release. Again, that's what's wild to me, that many people run a release candidate, but they do.
Yep.
So hey, hats off to everyone who does. We appreciate it because we need the feedback.
Hopefully they run it like on a secondary system or in a VM or something. Yeah.
Please be smart about it, everyone. Please. One last history question I have, and you're probably sick of hearing about it or talking about it, but of course there's a whole fork that happened. LXD became Incus. I don't want to dwell on that too much. Can you give us a little brief history? And then the more important thing, I think, is what's changed in Incus from LXD. So if somebody, a listener of ours, came from that world, knew LXD, what's different under the hood potentially?
Yeah, so I mean, there were a number of of reasons that kind of kept piling up over the years that got me to the point where I wanted to leave Canonical. So that happened in July 2023. Well, a bit, I think I announced it in June, and July was when I actually left. Up until then, I was effectively created the LXD project. I was the project leader for it, main maintainer, and we had a number of other maintainers for it. We had the project hosted as part of the Linux Containers project, which is the same umbrella project we use for LXC, like CFS, and a bunch of our other projects. And we were really pushing hard to run it as a normal community project. So maintainers was based on merit, not based on employment. So if you contributed enough, you'd get a maintainer, whether you were a Canonical employee or not. And people leaving the team at Canonical would keep having commit access and being maintainers because they still deserved it. We didn't have any CLA or the similar agreements to contribute, so it was very easy to take drive-by contributions. And being a Go project in the Go ecosystem, we were under the Apache 2 license because that's kind of the go-to, and that makes it very easy for everyone to consume it. And that really helped with some big wins. Like LXD was picked up to run all Linux stuff on Chromebooks. So the largest install of LXD were the Chromebooks, and that could not have happened if it wasn't under a different license, because Google is very allergic to running, especially AGPL on their platform. So it was a good fit. It worked great. We had a lot of contributions, and I think by Canonical project standards, after Ubuntu, we were probably the Canonical project with the most external contributors and most active contributors by a long shot. So by my standards, that was working pretty well. And yes, I had to fight for that over the years because there was obviously a big push internally of this is a Canonical thing. We need to make sure it's like all of our other projects internally, same license, same contribution guidelines, branding and logos and stuff. And I have always been resisting all of that and pushing back very hard on those things, being no, we need to run this as a proper community project. Yes, we're investing a bunch of resources in there, and that shows, and most people run it on Ubuntu, and that's why, and that's good for everyone. And my probably naive hope at the time I left was, look, I'm leaving the company for a variety of reasons, but I still like to get to be involved with the LXD project. Keep it where it is. I'm happy to still help with maintenance. I'm happy to still do YouTube videos on it. I'm happy to still contribute to it. I'll still do all of those things. And it's actually a good thing to have very active contributors from different companies in a good open source project. So it could have been actually a good thing for me to leave. I could have taken, the goal was to take customers that Canonical would never want to deal with because they're too small mostly. And kind of fill in that gap, which could have really helped with the project's adoption overall. And Mark didn't have it this way, basically. So he made it pretty clear in a call I had with him just before I actually left the company that basically he's so LXD being that kind of open source project as being a failure because we never managed to have more than 50% of all code contributed by externals, which I didn't know was the criteria for being a successful open source project these days, but apparently that is. There was that comment, and that the rest, you effectively just let it happen because of me and because you didn't want to lose me, but that now that all of that's going to be undone. And sure enough, I wasn't even at the door yet that the project was moved under the Canonical organization. Everyone who wasn't an employee got kicked out of the organization completely. So no more maintainers for anyone who left the project. It was employee only. They renamed the project from LXD to Canonical LXD, changing logos, changing all of the saying everywhere, so making it a proper Canonical branded project at that point. And that's how it was for a little while. So Obviously, the community didn't take it too well.
I can imagine not.
Yeah, so that led to the OpenSUSE maintainer of LexD, Alexa Sarai, to fork LexD as a new project called Incus. I started getting involved with that because that was easier to contribute to than LexD. So yeah, I got involved with that, and then there was a discussion amongst the maintainers of the Linux containers project of what do we do now, because we had a bunch of infrastructure and everything that was provided by the Linux containers project to LexD that was now sitting being mostly idle. And we've got that Incus project thing there that doesn't have any infrastructure. Okay, well, maybe we should just replace LexD with Incus inside of the Linux containers project and keep going. And that's effectively what happened. So like all of the lab infrastructure we had, all of the test automation, all that kind of stuff we had for LexD just moved straight over to Incus. And we kind of kept going. And for a number of months, that worked reasonably well. Like effectively, both projects existed under the same license. And so we would do some stuff, they would do some stuff. We would look at what we liked in LexD, we'd take those back into Incus. They would look into Incus, take what they liked into LexD. And we would often actually collaborate on bugs and the like. Like I was still in good speaking terms with a lot of my former reports. And I would talk to them about potential bugs and stuff. Some of them I would fix on my side, some of them they would fix on their side, we'd collaborate. And it was a reasonably good story. Up until, so that's the Incus project started around August 2023. First release was in October, and then came December, just before the holidays. Canonical announced 2 changes to the LexD project. One was switching the license from Apache 2 to AGPL v3. And the other was installing a CLA, so requiring everyone to sign the right to Canonical. Obviously, a bit of a problem. So on our side, we were not going to follow the relicensing because AGPL is just way too much of a problematic license whenever you want to, actually work with people who want to use your software. So we wanted to stick with Apache 2, which now meant we couldn't pull anything that happened in LexD. Because now it's a completely different license. So from that point on, we had to just stop looking at the repo completely. Like if I see a GitHub notification on an issue on LexD, I just unsubscribe. I don't even open it. Because if I go look at any example of code or anything from the LexD project, now we might be tainted by having looked at AGPL code and then implemented something similar inside of an Apache 2 project. The part that's slightly unfortunate for us is that it's not true in the other direction. They can still pull Apache 2 code into an AGPL project. That's fine. And the CLA is more of a problem for them in that direction because in normally any contribution they take in should have had a full license granted to Canonical. We obviously do not do that with our code. So now they need to put an exception effectively in every one of the commits they take from us. They put, like I mentioned, like this commit was under Apache 2 and it was not signed. The CLA was not signed. It's a bit of a weird move because they end up with a project that is not, they don't fully control the license of. Like their new code is AGPL, the rest is still Apache 2, and trying to figure out what line is what is a complete disaster. Like if a lawyer ever needs to figure that out, they're just gonna quit on the spot. Like it's basically impossible to figure it out. And the CLA is kind of the same thing. Normally the goal of a CLA is to ensure that any contribution from this point on, you own full copyright on, so that you can then include that in all of your other projects that you might want to relicense someday. With the way Canonical is doing it right now, they can't do it because since they keep taking some changes from us and mixing that with theirs, they have no real idea who's the copyright owner of any piece of code. So now if they take that code into any of the other projects, they're contaminating that other project with code they don't have full copyright on, which then prevents relicensing that stuff in theory. It's a massive mess. So what it means for us is that
with open source licenses in general, and that does sound like a nightmare scenario. So I don't envy you guys. That is tough.
Yeah, I mean, for us, it's been reasonably pretty clear cut, which is like starting December 2023, we can't pull anything from LexD and we don't look at the LexD project at all. It's actually not fully true because they still maintain their previous LTS. So they've got a 5.0 branch, which is still Apache 2. So that one, we actually still have tooling that looks at bug fixes in there because those we can safely look at. But the rest of the code, we can't look at that anymore, which means I'm also like, when comparing what do you have that XD doesn't, it's like, I don't really know. Like, I know a bunch of stuff we've added that I know they've not taken, but for the smaller stuff, I don't really know what they're taking and what they don't. What I know is they only have maybe a couple of full-time people on NextD these days, and we're doing too much on our side for them to be able to keep up. I know they've got like an internal spreadsheet of all of the pull requests that they need to consider for taking from us into LXD, and the document's just been growing and growing and growing, and they can't keep up with it.
Oh man, well, I was saying that was one of the things we looked at when we were looking at Incus for possible adoption in TrueNAS. Is I try and look at the health of the open source community around a project, and got a lot of contributors, so it's good to see. I'm glad that it was a successful fork in that sense.
Yeah, and we see a lot of different things, right? We see anything from the normal kind of drive-by, just fixing something there. We tag a bunch of issues as easy, which are like not necessarily actually easy to do, but fully understood, so that we can mentor someone through it. So we've got a bunch of those issues, and that's actually a good chunk of the contribution count over a year. Is we've got students at the University of Texas in Austin that get sent by their professor every year in their virtualization class to contribute to an open source virtualization project. And they tend to come our way because we're known for being pretty good at mentoring and merging things pretty quickly, which is good because they get their extra credits pretty quick if they go with us effectively. But that also means we get every year something between like probably 20 to 30-ish students contributing to the project. So that's a pretty big count. But these days we're also seeing a bunch of companies contributing directly to Incus, which is good. For a while, there were a bunch of companies kind of doing that, but a bunch of them were actually just paying me through my private company to go and do some work for them and then contribute that as sponsored work. So there's been a bunch of that. But then some of those have now adopted it enough internally that their developers directly contribute to Incus as well. Like a recent example is the Linstore storage driver that was contributed in the previous Incus release. That came as a contribution between Magalu, which is like a retail but also public cloud platform in Brazil, and a university in France that also needed the same features. It actually both ended up working together, and I was also effectively being paid to help with review and design and stuff on it at the same time. So that was like one of those cases where like 3 companies were actually involved on the same feature, which is really good to see. And yeah, we're hoping to see a bunch more of that over the next few years. Like for me, a good half of a project is a project that is not tied to a single company, that's got a bunch of active companies involved with it. We're ready to get that with the maintainers for Incus. Like basically the maintainers for Incus are all of the previous LexD maintainers, because none of us are at Canonical anymore at this point. But that means you've got maintainers that work for Geico, Microsoft, Netflix, Suzy. So we've got working for a bunch of different companies. They're not necessarily paid to work on this. They might have some amount of paid time for open source stuff. But that's still quite a bit healthier than having all the maintainers work for the same company. And at that point, that company's agenda is going to have a lot of weight, which is not really what you want.
That's what makes it attractive to us on the TrueNAS side, because it mirrors what we see with like OpenZFS, for example. It's not just IX or not 1 or 2 other companies controlling it. It's a pretty healthy mix of other corporations and people collaborating on similar functionality. I think we even got our first kind of Incus fix from one of our folks contributed upstream. So hopefully, as a result of all these changes, we'll see some more TrueNAS inspired contributions down the road as well.
Yeah, that'd be good to see.
Yeah, we're currently shipping in Fangtooth. We're going to have the Incus 6.0 LTS version. So, I mean, with all these different contributors coming out from various companies, organizations, is there any kind of sort of new changes that you have in sort of the stable long-term branches that you might be able to say, hey, these are going to make it to the next LTS, and then we'll be able to sort of include it into a future release of TrueNAS? So, a little bit of early preview things, kind of thing. Stuff
so,
like
I mean,
that.
We've been pretty darn aggressive as far as feature backport into the LTS. I mean, more aggressive than I ever did with LexD. Like normally, like a proper LTS would be basically bug fix only, right? Bug fix only, security only. We've not really done that with our LTS. We've usually backported any kind of improvement that doesn't require data migration, doesn't cause any API breakage, or doesn't cause any database changes. But that still involves a lot of things. Like we've been able to probably like 80% of what lands in the monthly releases effectively makes it to the LTS at this point. The main three features now that I can think of that did not make it into the LTS and won't is OCI support. So running application containers, that's just not in 6.0. That's going to be a 7.0 thing for LTS. Running Linstore, that's another massive one. So new storage driver. We don't push new storage drivers to LTS. So that's another one that's going to be a 7.0 if you're not using the monthly releases. And another one we merged very recently, which normally would be the kind of improvement I would like to put in the LTS, but because it's a database change, we can't, is network address sets. So if you do advanced firewalling and you want to have like a bunch of pre-made address sets you can put into your firewall rules, that's a very convenient feature, but that needs new database tables, so we can't do that inside of the LTS.
So that would require sort of like a migration process in the middleware. And I know some of our users are concerned about, changes and things like that, because we've had a bit of change. We went again from, Kubernetes to Docker was a change. Now people are somewhat concerned. They're saying, well, now you're going from, your previous virtualization to Incus powered. You're still leveraging the same, KVM and QEMU under the back end though.
Exactly.
So, yeah. It's like you said before, it's like a Libvirt to Incus change. It's not, we're not getting rid of KVM. Don't panic, guys.
Yeah, please don't panic. And really quick, let me just get on my soapbox for 2 seconds about that. So folks who've been paying attention, when we did scale, the VM section has been the last section I've wanted to go and do kind of a massive overhaul to for a long time. It was essentially a fork of what we had with Core on using Beehive as the virtualization. It hadn't changed much. So this has been a long time coming, and being able to move it to Incus, I think, is really going to lay the foundation for a lot of cool stuff that's going to happen in TrueNAS around virtualization, containerization, LXC stuff. Again, I've wanted to do for years. We just haven't been able to get to it because we had other more pressing fires. But again, it's a good thing. Everyone should be excited. I think it's going to change a lot over the next couple of years.
Yeah, and the user experience is pretty good in that, like, you get to access the pre-made images. So if for just about any Linux workload, you can basically just pick a pre-built thing and you're just done. Like, you don't need to do an ISO, attach it, install it, all that kind of stuff. You still need to do that for things like Windows, but for anything else, it's a lot easier.
Just plug and play, just click and go. It's very nice. So again, I'm looking forward to getting the release out here. We're just a few days away. Again, try it out. We'd love feedback. We are still calling it experimental on this release because we do have a lot more we want to do to it to kind of harden it and make it more enterprisey for our release in the fall. So stay tuned. I'm sure we'll be talking about that in the future. But speaking of the future, Stéphane, what kind of things do you see landing in Incus? I guess, do you guys have a roadmap or any cool new stuff coming down the pipe? I saw some rumble, something called IncusOS. Can you enlighten us at least briefly on a few things?
Yeah, I mean, for Incus itself, we've got a bunch of issues open, but no super clear roadmap. Something we do monthly releases, so it's always whatever is ready gets in the release, basically. There's still a bunch. Well, on the VM side, we've done a lot of work recently. We did things like USB devices and that kind of stuff, which actually you get in 6.04. So that's one of those things we backported to the LTS. That will be useful potentially for TrueNAS users, because that will let you attach like a USB hard drive, USB network adapter, which is useful for things like Windows, where you don't have the right drivers loaded yet, that kind of thing. So that might be pretty useful. Otherwise, we're never feature complete. We're close to what we want for VMs. The one missing piece we're working on right now is memory hot plug, so that you can grow the memory of a VM, not just shrink it. That's one of the main kind of gaps we still have right now compared to containers. So we're plugging that one. Otherwise, like the bigger pieces I mentioned earlier, the ability to run those OCI images inside of VMs. So that's one thing that's one of the larger features on the roadmap. Otherwise, we've got a bunch of network-related features we're kind of working on. We've got Oven as an SDN, and we're adding more and more features to that. Like, a very common thing we're dealing with these days is migrating people away from VMware, which is pretty easy to do. We've got good tooling to do that, to move. Connect to an ESX or connect to a vCenter and slurp all the VMs, doing like progressive data transfers, and then do a cutover. So there's tooling that does that for Incus. That works pretty well. The networking side tends to be the trickier piece. If you're running just ESX at home in a home lab, that's easy. You're probably just like on a shared VLAN or something. We can just bridge into that. That's nice and simple. But those running corporate environments with NSX, so running like all of the virtual networking stuff in VMware, that's trickier. So we need to add a few features on our side to allow kind of bridging NSX and Oven temporarily during migration. So there's some work around that's happening. And then another feature that will actually tie us into IncusOS is we need a simpler SDN for our internal services. So if you're a home lab at home and you just want to run 3 machines, we need to run some amount of control plane services as containers, and we want those to be accessible from all of the systems within the cluster and to be able to migrate between all systems within the cluster. So we're looking at doing like a BGP mesh effectively automatically within the cluster so that we can do that. It won't be fancy. It won't have like load balancers and ACLs and all that kind of stuff, but we don't need it for the internal hosting of management services effectively. So once we have that will give us like somewhere to put things like if you want to deploy an authentication stack, or you want to deploy your observability stack, or if you're using something like Oven, Ceph, or Linstore that all need some kind of control nodes, that will give you somewhere to put them to. So that's kind of the idea around that feature. And that ties us into IncusOS because currently, so there are kind of we've got kind of 3 stories for deploying Incus. One is just install the package from your distro, where basically all the Linux distros, nice and easy, install it, you're done. Then we've got Incus deploy, which is Ansible effectively against Debian, Ubuntu, or CentOS to deploy clusters, including things like Ceph, Oven, that kind of stuff that you can put on top of it. And it does like all of the PKI management, security, key distribution, all that kind of stuff for you to do it correctly. But in that scenario, you still end up with some Unix snowflakes. Some of the servers will be running the control plane for Oven, for Ceph, for those kind of things, and the rest are just compute. That's not great because if you forget which one are running your control plane, which I've been known to do occasionally on some of my clusters, and you evacuate and do maintenance on too many of those at the same time, but then your cluster freezes, which is not great. So what we actually want to do, and also at scale, like when I've got some customers that are running in the thousands to tens of thousands of Incus servers, it's not really practical to manage distros and package updates and that kind of stuff at that kind of scale. It's just unpleasant. So that's where IncusOS kind of comes in, which is like a modern, completely immutable Linux distro. So it uses all of the security features. So you can use Secure Boot to validate the early boot, TPM measurement for everything that's loaded afterwards. The disk images are read-only and read with DM Verity. So we do automatic like signing validation of everything that's being read from disk. The persistent data is TPM encrypted and tied to the boot state. So if anything changes on the system, you can't access the data effectively. So we've got all of that stuff in place. And the only goal for that image is boot, be able to self-update, download and run Incus, and be able to auto-update Incus. It's extremely locked down by design. There's literally no shell on the thing. You can't SSH in. There's no SSH server. You can't log in at the text console. The text console only shows you a status message. That's it. All interactions must be done through the API. And that makes it a lot easier for things like compliance in corporate environments and the like. Like there's literally no way you can run a scanner on this thing. Like the file system is read-only and there's no shell. You can't even like this is the definition of a black box appliance, which you just run and you can analyze the image offline if you want to, but the running system, you can't mess with it. And it's guaranteed that every one of those are bit for bit identical to each other. So no more Unix snowflakes and great at scale.
Super important for security, reducing complexity, reducing edge cases. Ask us how we know, because we fight that battle on the TrueNAS side with people wanting to go in and, you disabled apt. How come I can't go and just customize my OS? And I'm like, it's an appliance. It's not an OS. Like, stop it.
Like you're going to need to update that machine at some point and all your custom stuff's going to break.
It's gone.
Exactly. So no, that's the idea there, and it actually fits 2 demographics at the same time, which is kind of interesting. It fits both the large scale environments where you really don't want to have to think about OS maintenance and all that kind of stuff. So that's great for those kind of guys. the other one is actually some of the home lab environments. Like we see a bunch of people who actually quite enjoy the appliance type model, whether it's TrueNAS or Proxmox or VMware ESX. Just install a thing and then run stuff on top of the virtualization platform, but don't micromanage the platform itself. And IncusOS will be great for that because you'll be able to run it like on a few Intel NUCs or Raspberry Pis or something like that. And you don't need to care about the virtualization platform. You know it's going to be there. It's up to date. It's secure. It's fine. And you get to play with all the stuff you run on top of it. So
it makes total sense. We were just having a thread on the forums this week about people who run virtualization. What do you use it for? And I was like, that's why I run Home Assistant. I run HAOS because it does all the add-ons. It's a lockdown environment. It's just too convenient. They've done it right. I don't have to think about it. I just click a button and it updates. And it's not like, I have to go in and change those packages by hand, all that nasty stuff. I have a busy weekend. I have things to do too.
Yeah, exactly. I mean, it's mostly a matter of, like have the time for what matters to you. Like maintaining dozens of servers and stuff that it can be fun for some folks. Like some people really like doing that for their home lab. That's great. Once your home lab turns into like a production data center environment, you're going to find that a lot less fun. You're going to want it to just be correct all the time and not have to micromanage it.
100%. So once I moved everything out of jails into Docker apps originally, and my life got so simple, I was like, so updating Plex and my whole stack now takes 5 minutes on a Friday.
Yeah.
Great. I get all this time back. What am I going to go do now?
Home labbing can be fun. Home prod is where it starts to be a job then. No thanks.
Yep. So as we wrap up here, Stéphane, first of all, this has been awesome. So really appreciate you being on the show. But I want to ask, because you're about to get this influx of more TrueNAS community users. And again, be nice on the Incus forums, guys. We're watching. Is there anything we can do on the TrueNAS side to help foster any better collaboration between ourselves, and the Incus project?
Not that I can think of right now. I mean, obviously, like people who have Incus questions are definitely welcome to come ask them on our forum. There might be a slight difference in approach there, in that TrueNAS obviously asks everyone to use TrueNAS directly, the UI, to drive Incus, whereas on the forum, all of the Incus folks will be like, so just run this command.
Sure.
So there's, like, if you do that, be careful. Like, looking around so far, it doesn't look like TrueNAS is doing anything particularly weird with Incus. So long as you don't do anything particularly weird with the CLI, it shouldn't really cause issues. But it's hard to know what's going to happen down the line, obviously on the TrueNAS side. Like as you folks start using more and more Incus features directly from TrueNAS, that might start conflicting with people doing things by hand. So, be careful with that.
And we want folks to look at Incus and say, hey, if there's a feature that doesn't exist that I want in Incus, go work on it, contribute it. And then when we pull in the next LTS update, we get it into TrueNAS, and we can now go expose that checkbox or that feature or that knob in the UI, because we want to build it out and make it first class.
Yeah, exactly. I expect some people are going to be trying to do stuff through TrueNAS, finding something is missing, potentially come ask us like, hey, how do I do this stuff with Incus? We tell them, and it's like, okay, well, then it's just a TrueNAS problem. So let me go back to TrueNAS and be like, can you just wire in this feature, please?
Absolutely.
So we're going to see some of the back and forth that way. Yeah. Because
we want those requests.
Just like any project, you need the user feedback to know what actually matters. Like, otherwise you're going to, like, it's not feasible for you folks to support everything Incus does.
No.
Like, even our own UI doesn't do it. Like, it's mostly like, what matters to people, and then do that.
We're still primarily a storage appliance, and there's a gazillion Samba features or ZFS features. We don't expose all of them because sometimes there's a complexity element that doesn't play well with the needs of the 99.9%. I understand there's that 0.001% who needs that weird knob, but to go turn that on and break everyone else sometimes is a tough call.
And it's going to be interesting to see, kind of some of the things you're going to end up contributing back, like also some, whether it's new features or bug fixes or performance improvements and things. Like, there might be some usage pattern around ZFS on TrueNAS that's unusual compared to what we are dealing with today. That being said, I think some of the craziest stuff I just fixed last week, which wasn't TrueNAS. It was someone doing something really, really weird. They were running a system using Incus that had around 150,000 snapshots.
Oh, wow. Well, that's a problem no matter what.
Exactly. Yeah. So, like, And the problem with Incus is that some of the queries were trying to get the size of each of the snapshots, and it was literally doing it individually. So we were doing 150,000 ZFS get calls, which was not good. Also, because ZFS itself has performance issues at that kind of scale. So ZFS get for a single snapshot was taking about 3 seconds, which was not amazing. And then multiply that by 150,000, and that was really not good. So anyway,
we've had this argument with our users before, Stéphane, where we have to tell people, look, unlimited snapshots means there's no cap on it from our side, but there's a practical limit to how many snapshots you can do, which is why TrueNAS will warn you when you get to certain points and say, hey, your performance may now start being impacted because there's a cost. Nothing.
You've got the copy on write accountability cost, which is already quite bad on the performance side there. And like we've also seen, like, so ZFS upstream did some improvements to make it go a bit faster on some of those queries, which is good. Like ZFS 2.3 was quite a bit better. And then what we effectively did is we added a hint in the storage drivers that can be used. So if an API call is likely to hit multiple snapshots, it can effectively do an initial call being like, hey, for the context of this request, I'm going to access multiple snapshots. Please pre-cache everything. So that way we do a single ZFS list that that gets the data for all the snapshots. We store that in memory, and then we just access it from the in-memory cache from that point on. So for that particular user, we went from around 15 minutes to list everything down to 3 seconds.
We do similar kind of tricks on our end too, where it's like, I know this is an expensive operation. Let's please do it once, and then pull as much data out as possible.
So there's still gonna be some code paths where we're gonna have to deal with each snapshot. Like I would not recommend someone like that try to do like a copy where we do send receive. That would probably not be super pleasant.
Well, at a certain point, you're going to have to obey the laws of physics there, especially if you're one of those people still doing this with, spinning drives on the back end.
So, and like, it was literally a case of like, I think this guy literally noticed that we can do snapshot scheduling, and he turned on snapshot scheduling every minute without putting an expiry, and being like, that's cool, I've got a lot of granularity. He's like, but maybe don't do that,
Just because you can do something doesn't always mean you should. But this has been a wonderful episode. I mean, a very special thank you, Stéphane, for coming on here, chatting with us, giving us all this fantastic historical detail around Incus and the containerization projects, giving us a glance sort of at, potential things coming in the future. It's been a fabulous insight for us, both from an engineering perspective as the developers on TrueNAS, as well as I'm sure our audience who is listening and furiously scribbling down notes so they can be ready for the updates there. Again, if you guys do go over to the Incus forums to introduce yourselves and get a little bit more information, again, please play nice. Remember, you're representing our community. If we have some of the Incus community coming in to welcome us, give them a warm welcome as well. So thanks everybody for tuning in today. Again, Stéphane, we appreciate you coming in. For those of you who want to submit your questions, you can submit them to t3@truenas.com. If you have something you want to go through and send to Stéphane, we'll courier it over to him, but we'll kind of act as a little bit of a filter here for you. You can drop a message in the comments section below, especially if you're looking forward to Incus and Fangtooth. Don't forget to do the usual YouTube things, like the video, subscribe so you don't miss our next episode. Happy updating to Fangtooth, folks, and we'll see you next time.